The first property that we'll talk about with any polygons is related to triangles, and that is that the sum of the three angles inside of a triangle add to 180 degrees. So you can use that to find missing angles. So if we know one angle is 65 and the other angle is 34, those add to equal 99, so we can subtract 180 minus 99 to find that our third angle is 81 degrees. You'll often see problems that have overlapping triangles or shapes, in which case you just need to pay attention and make sure that you see how many triangles there are. So first, there is a right triangle here that makes up about half of the drawing. There's another triangle off to the right. It appears to be an obtuse triangle, but those triangles also overlap to form a third triangle here in the middle, and two angles of that triangle are marked to be congruent. So whatever they are the same, and they have to add with 124 to equal 180 degrees. So we can assign a variable like x, since they're the same, set them both as x, and we can begin to write an equation. That the three angles add to equal 180 degrees, and then solve. 2x equals 56, and then divide by 2 to find that x equals 28. So both of these angles are 28 degrees. There are a few more angles here because we could actually look at the far left portion as a small triangle and the upper right portion as another triangle. So we can find these other 4 angles that we don't yet know. To find those, it would be in our best interest to know that a straight line is 180 degrees. So we can subtract 180 minus 124. To find the missing angle over here. So that's 56 degrees. And it would be the same process on this side, so we'd also get 56 degrees. Now we know we have this triangle with the right angle. So if we have 90 degrees, 56 degrees, we can find the third angle of this small triangle, which is 34 degrees, because the 3 angles have to add to be 180 degrees. Also over here on the right, 53, 56, and something we don't know, we can assign a variable for any of these at any point. We could x plus 56 plus 53. And then solve the equation. So we got 109, subtract that from 180. So this angle is 71 degrees. So next, once we know that the angles of a triangle add to 180, we can think about other polygons and how many degrees would all of the angles of a quadrilateral add up to be, or a pentagon, or a hexagon. So In order to figure that out, you could draw diagonals. And if you draw the diagonal of this quadrilateral, you get two triangles. There are two triangles within it. And the triangles, we know the angles add to 180, so that means it's 2 times 180. For the pentagon, we could do the same thing. You only draw the diagonals from one of the vertices, from one vertex, because otherwise we'd get overlap. So then we get 3 triangles. So that means all the angles must be 3 times 180. And we'll do the same process with the hexagon. Draw all the diagonals, and you get 4 triangles. So all of the sum of the angles of a hexagon must be 4 times 180. So when there's 4 sides, there were 2 triangles, 5 sides, 3 triangles, 6 sides, 4 triangles, so it seems like it's always 2 less, and that is in fact the case. For the angles measures of a polygon, it's always number of sides minus 2 times 180 degrees. So if it had 37 sides, you would subtract 2 and then multiply by 180, 35 times 180. If a polygon is regular, a regular polygon means that all sides and angles are congruent. So if all the angles are congruent, you would take that formula and divide by however many angles there are. And that will tell you what one angle of the regular polygon measures. So our example that we're going to work out actually has to be worked in reverse, because we're told how much one angle measures and asked to find how many sides it has. So you take the formula, equals the measure that we're told, and we need to solve for n, solve for the variable. So I would distribute the 180 and multiply the n to the other side. So we have 180n minus 360 equals 157.5 times n. Subtract 180n. We get negative 22.5n equals negative 360. Solve by dividing. 360 divided by 22.5, and we get n equals 16. So that means it has 16 sides, or we could call it a 16-gon.